Hello, everyone. I'm Dave Grahaki,
And I'm Howard Orlowski.
and we are on one of the app teams at Microsoft focused on delivering some of the awesome app experiences that ship with Windows. Calculator, of course, but also apps like Movies and TV and Notepad. Today we're going to be talking about lessons learned from open sourcing Windows Calculator. Now, what we're going to be talking about is based on our own experiences, but we believe those lessons can apply to your open source projects as well.
So I want to tell you the story of how we got here, but I only have about a minute for this part, so let's see how it goes. Back in 2014, we were wrapping up the development of Windows Phone 8.1 and moving on to the combined release of Windows Phone Windows 10. Some apps were being rewritten as UWP, but all apps were undergoing a number of changes in order to conform to the updates for Windows 10. Now, internally, teams are also undergoing a number of engineering changes, like moving on to Git for code management and Azure DevOps for cloud building. And so a central team was formed in order to try to solve the problems that all these app teams were having, and that's where we stepped in. What we ended up doing ended up working out quite well for the large pool of developers within Microsoft, but there's so many more developers out there in the world that are having the exact same set of problems. So that thinking finally got us to consider that whenever we start new work, we should start that work with the question, how can we do this so that it helps external developers too?
So we thought the best way to help out developers was to just open source one of our projects on GitHub and just start operating in the open. Now, our goal was to help external developers, but there were a few other specific outcomes we expected as well. First, by allowing open contribution, developers can contribute to the product, leading to increased diversity and higher code quality. We could build trust and positive public perception with both the developer and consumer audiences. We could experiment in the open and share our learnings with the community. We would also be sharing app best practices, and developers can reuse portions of our code to build their own M365 experiences. And finally, we would enable two-way learning, where not only would we be learning from the community, not only would we be sharing our lessons with the community, but we could evolve how we work by learning from the community as well. So, why Calculator? There were a number of reasons we decided to lead with Calculator. First, let me tell you, Calculator is used by a lot of users, and we thought that this familiarity would drive interest in the project. It is also kind of cool to be able to contribute to such an iconic Windows app. And there were lots of opportunities for contributions. We were excited to see where the community would take the project. From a product perspective, Calculator is in pretty good shape, and engineering-wise, it was looking pretty good as well, being built and tested on the latest tooling. It doesn't require too much specific domain knowledge, which means it could attract developers from all levels. And it's a great example of a modern application that has a responsive layout and is fully accessible. It's also a great example of fluent design. So now I know many of you are probably familiar with GitHub, but I want to take just a moment to talk about it for those who are not as familiar. Open source has been mainstream for some time now, and GitHub is the place for open source software online, with more than 40 million users and over 100 million projects hosted on the site. It's easy and free to create an account. If you don't have one, I invite you to do so. But everything that we're talking about today is public, which means that even without an account, you can go check out the Calculator project online today. All right, so back to Calculator. And I love this picture. This is an actual photo of a whiteboard in our office showing all the steps that we followed to prep the project. Now, keep in mind, before open source, Calculator was a full production app hosted on internal systems, and we were quite new to open source ourselves. Fortunately, Microsoft has an open source programs office to help us out. They provided a checklist. I won't get into all the details, but the steps that we followed to get our app on GitHub. It included things like making sure that we had the right contributing documentation and getting sign-off from legal and PR teams. Now, lots of companies have open source program offices of their very own, but even if yours doesn't, that is okay. There's lots of great resources online to help you get started, and we'll be sharing some links to those resources at the end of the presentation. Now I'm going to hand things off to Howard, who's going to add a little clarity to the blurry sticky notes in the photo.
Thanks, Dave. There we go. One of the first things that we did to update both our closed and open source projects was to migrate them onto an Azure DevOps feature called Azure Pipelines. The pipelines just allow us to automate everything that we needed to do for our builds. And one of the great things about Azure Pipelines is that they're free for open source projects. So at a high level, a pipeline is just a series of steps of tasks that you need to do for your build, and they can be triggered either by an event trigger or happen at a certain time event. For our project, we have a continuous integration or a CI pipeline, and its main focus is to both build and test the app anytime a new pull request has been submitted for review, or anytime we've taken a change directly into master. We also have another pipeline we call the release pipeline, and its goal is to do everything that the CI pipeline does, but additionally automatically deploy that app update to the store. So here we're looking at the pipeline editor within Azure DevOps. We're actually looking at the continuous integration pipeline that we have, which does the building, the testing, and the automatic deployment. And at the moment, I'm just kind of showing what it's like to add a PowerShell script task. Super easy to augment your pipeline. So now we've kind of switched back to GitHub, and we're looking at a pull request that came in. I'm going to zoom in a little bit more at the part of the bottom. And so this is awesome. Like, the integration of Azure DevOps into GitHub is seamless. Here we can see that all the checks within our pipeline passed. Had any of them failed, the merging into GitHub would have been blocked. In this case, merging is still blocked because nobody from our team has actually reviewed this change yet. So another way that you can get more information is by clicking on the checks tab within the pull request. But what we're going to do is click on that link at the bottom, which is going to take us directly to the Azure pipeline that was kicked off for this pull request. Now, there are a few things I want to point out on this page. The first, you don't have to sign in. Everything that's happening here, just like on GitHub, is open. It's public. The next is this really interesting artifacts thing. These are build artifacts. The pipeline allows you to publish any intermediate build output as a build artifact, and we've chosen to publish out the AppX bundle that's built as part of our pipeline. That way, anybody can download the build as of a specific pull request. Another thing to note is that while we do build for 4 architectures for what we publish to the store, for the purposes of our PR pipeline, we only build x64 in order to speed the process up. So jumping back to GitHub, we're looking at our README. And one of the things that we have on our README is an image that's in open source land. It's called a badge. Badges allow you to show various status updates of your project to the community in a very easy to find way. In this case, there's something kind of wrong here, and I'm not sure if you can tell. So I'm going to zoom in a little bit more just in case you're not seeing it. So something clearly went wrong with our CI build from Azure. So let's just we're going to click on that badge and go over to Azure DevOps and see what's going on. So in this case, we have 4 tests that failed. Let's understand why. So in this case, like I said, our PR pipeline for the CI is only building out x64. And in this case, a recently merged change for x86 ended up breaking 4 tests. So this type of problem has only hit us twice in the past 7 months. So we're monitoring this situation to see if we need to maybe build all 4 in the future. But for now, we're leaving it as is. This problem's already been fixed. So an even better way to author your pipelines is to use something called YAML, which is a markup language. And the great thing about it is that it allows you to store your pipeline configuration right in line with your code. So it's checked in with your repo. So now, in the calculator repo, we have 3 YAML files representing 3 different pipelines. One of them is that CI pipeline we were talking about, and another one is that release pipeline that also does that automatic deployment to the store. Now, I don't expect you to understand what this looks like, but I just wanted you to see what YAML looks like. So anytime you see one of those dashes, that's a task or a step that's going to execute as part of your pipeline. And everything that's underneath it is just a configuration parameter for what your task is going to do. So now, luckily, you don't have to know YAML to use it. Azure DevOps has a really nifty feature in the pipeline editor as a View YAML button. Just press that, and it spits out all the YAML that you need. You can just copy paste that, and then add a new YAML file to your project and just be off and going. So when you have a product that you want to open source, there are often a lot of times when there's stuff that you just don't want to make public. And we were in that situation too. And so we started using something that we like to call the sidecar. And the sidecar allows you to separate the product from the project. So at a high level, you can just think of the project as the set of things that you want to be public. You want people to be able to see and reuse, while the product is what you're actually intending to ship to your customer. So the way this works is, examples of what we had to do for in our sidecar included making use of, we replace our dev icons with the retail icons. We also have, that's where we store the certificate that we use to sign our files. We store our images and our text that we use for the Microsoft Store submission. We have our localization process because that happens to rely on internal tooling. And finally, we also have our graphing libraries for our graphing calculator feature because those are not currently available for public reuse. And the way this works is pretty simple. So you just have a second repo. That second repo, in our case, happens to live in Azure DevOps, but there's no reason that couldn't just live in GitHub as a private repo. You keep the exact same file and folder structure, and it only contains the set of things that you need to convert a dev build into what you consider a retail build. So anytime you make a change to that repo, it creates a universal package. A universal package, just think of that like a versioned NuGet package. So we'll get a new version from that, and we'll just open up the pipeline, the YAML file in our public repo, and we'll update the version number that we're trying to download. And the great thing about this is it's now versioned. So now for servicing, if you ever need to recreate a previous build, you know exactly what version of those internal files you need to use again. And so in practice, the way this would work, imagine this is a clone of your repo on the build machine. And so we're just going to go off and download that version 22 of the universal package. It's going to download, extract, and then replace those files right on top of the cloned repo. So in some cases, it's going to replace files like it would with our the dev icons going to the retail icons. And in other cases, it's actually going to add files that weren't there before, like our graphing library. Now, earlier I had mentioned that our release pipeline does automatic deployment to the store. And I just wanted to touch upon briefly how we're doing that. So Azure DevOps has a number of extensions that are free that you can use in your pipeline to add additional functionality. Microsoft publishes out one of those called the Windows Store extension. The Windows Store extension allows you to automatically publish an updated flight or retail submission of your app to the store. In addition to one for the Windows Store, there's also one available for the Google Play and Apple App Store as well. So the way you do this is quite simple. In the pipeline editor, you can just search for an additional extension, in this case, the Windows Store. You add it right into your pipeline, and then you just click on it to configure the property specific for your app. Now, another way that you can do automatic deployment to the store is with the PowerShell module called Store Broker, which also happens to be open source, and it's a project that we maintain. In fact, this is actually the way that the majority of Microsoft apps get published to the store. And the Windows Store extension that we were talking about just moments ago, an in-development version of that is being updated to be built directly on top of Store Broker. Now, testing is important, especially automated testing, if you want to ensure a quality product is reaching your end customers. And we currently employ both unit testing and UI testing. For UI testing, we're making use of WinAppDriver, which is a Selenium-based framework for testing Windows applications, be they WinForms, WPF, or even classic Win32, and certainly UWP. But talking about it is one thing, and showing you is another. So while it works both locally on Visual Studio and on your desktop, as well as in the cloud with Azure DevOps, here I'm showing it locally. It launches the app, and it has a series of button presses and gestures in order to mimic end-user behavior. Now, unit tests are great, and we have a lot of them, but they can't test something as simple as, does my app still launch and not crash when someone clicks on it? And that's where these fit in. So when we launched the open source project, we didn't actually have UI tests. We previously did, but they were based on a framework that was internal only, so we launched without them. But that's the great thing about open source. The community stepped in. In this case, a member of the WinAppDriver team came in, and with that pull request, they added the first UI test to our project and got us all connected with WinAppDriver. Since then, we've gone ahead and we've updated and added additional UI tests. But if you're interested in adding UI tests to your own application, I highly encourage you to check out that first pull request because it has everything that you need to get started with tests in your own application.
So another great way to test your product is to get it into the hands of actual users. And one of the things that we love about Windows Calculator is it is used by so many different types of users. To make sure that we're building the right feature for everybody, we follow a user-centered design approach to feature development. It is a data-driven and iterative process that follows a cycle of ideation, pre-production, production, and release. Now, I'm not going to get into the nuances of that actual cycle, but it took us a little while to figure out how to operate this way in the open. But now, if you check out our documentation, we have figured out how to follow a user-centered approach for Calculator on GitHub. Now, that's not the only thing that we had to figure out. We did have to also adjust to the new normal of our team working in the open. Now, what you see on the screen here is kind of a representation of what our team looked like before open source. Now, there's PMs and designers and some other folks in the mix here too, but the takeaway is that everyone was focused on building a great product. Then, with open source, our team grew quite substantially. And we found that some of our team was now focused more on managing PRs, engaging on issues, or otherwise engaging with the community. We were all still focused on building a great product, but we also wanted to build a strong community. So the day-to-day operations of our team shifted a little bit. To help with the transition, we tried to automate as many of the administrative tasks as much as possible with the assistance of some bots. As we alluded to earlier, we manage a number of different projects, some on GitHub, some in DevOps internally. And we wanted one view in DevOps of all of the different work items expanding across all these different products. So we built a sync bot. And the sync bot performs a two-way sync of GitHub and DevOps issues so we could have that view. It's built on top of PowerShell for GitHub, which is another open source project we maintain. You also might have seen Microsoft Bot appearing in certain Microsoft projects, including our own. We've configured it to reply with some canned text anytime we add a certain label. Here, a community member proposed a new feature idea. I added a label, and then Microsoft Bot responded with some text telling the community member what to expect next. But you can't automate everything. And from the very beginning, we felt pretty good about all of our contributing documentation. However, very early on, there were a flurry of PRs fixing one-off spelling mistakes and confusion when conversations were split between multiple issues and PRs. So we've iterated quite a bit on some of that documentation. This documentation serves as the rules of engagement for the community. You do get to set those rules for your project, but it is important to be transparent and straightforward with them.
Code will never be perfect, and we knew that when we launched. But we figured that fixing some of these issues in the open would actually be beneficial to other developers in the community. And in fact, the community's been great in helping rallying around fixing some of these issues. One of the earliest contributions that we had, a community member created a Clang format file that helped enforce automatically the coding conventions that we had within our project so that we wouldn't have to worry about that when reviewing pull requests.
Also, partner awareness is key. We tried to let everyone know what our plans were with getting Calculator on GitHub, but we missed one or two partners who were a bit surprised by our announcement. We followed up with them, and now they're very supportive of our efforts, but it kind of emphasized to us how important it is to let everyone know about your open source plans, just so they have a chance to provide feedback.
Attention breeds trolls. We had one pull request that tried to improve the performance of our application by deleting the entire code base. We also have had a number of comments that just don't bear repeating. An important thing is to have a solid code of conduct that you can refer to when things take a bad turn. And some of the best advice that I can give you is to never post your first draft response. Bang it away, get all that frustration out, and then just delete it and start again. But trolls account for a tiny fraction of our community. In fact, our community members have been awesome in stepping up and to help deal with these trolls before we've even had a chance.
So, was it worth it? Well, we think the answer to that is a resounding yes. We've seen more than 50 feature ideas come in from the community, and to date, we've had over 370 PRs. Even more exciting, there have been over 500 community members involved in the project from more than 45 countries around the world. That is just so cool. The global community has helped identify gaps, like how the Pyong, a common Korean area unit, was missing from our unit converter. There's also a community-driven effort to add Clang compiler support to our math engine, which powers all of the actual math going on in the app. And finally, you might have heard of Uno. It's a product that helps you build cross-platform native apps using C# and XAML. The team behind Uno shipped Windows Calculator on iOS, Android, and the web as a demonstration of their platform and tools. And these are just some of the examples of how the community has impacted the project. Whew. we sure covered a lot in 20 minutes, but I want to make sure that everyone here walks away with 3 main takeaways. First, open source is both mainstream and a practical development model. We found that working with the community on Calculator has led to Calculator being a better product, and we think that you could see benefits in your own open source projects as well. Remember, open source works for commercial products. You can both open source your project and ship your commercial product at the same time. And finally, GitHub integrates seamlessly with Azure DevOps and pipelines. We showed how we use WinApp in pipelines to test Calculator. But between GitHub and Azure, there are hundreds of integrations with the tools and service your team is probably already using today. So on that note, I want to thank you all for joining us. This slide is important. Please take a photo of this slide. It has an important link. It contains all of the references that we talked about today. Otherwise, thanks again, and enjoy the rest of the conference.
Thanks so much.